Hi everyone, in the last video we looked at summing geometric series, and if we've discovered that if we had a geometric series a plus ar squared plus dot 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 all the way to ar to the power of n minus 1, then we could sum that series using this formula where a is the first term, r is the common ratio, n is the number of terms in the series, and we have a times 1 minus r to the power of n, all divided by 1 minus r. And that's the sum of this series as long as this series is a finite series, meaning that there's a finite number of terms in the series. So we're going to look at a couple problems where we apply this formula. In the first problem, we're told determine the sum of the first 10 terms in the series 3 minus 6 plus 12 minus 24 plus 48 minus dot dot dot. The first thing that we need to do is we need to figure out if this is what kind of series this is. Like, is this a geometric series? Is this an arithmetic series? Or is it some other kind of series that we'd have to use some other method to sum over? So here, if we look at the second term is minus 6. If we divide that by the first term, we get minus 2. If we take the third term and we divide that by the second term, we get minus 2. If we take the fourth term in the series and we divide that by the third term, we get minus 2. And if we take the fifth term and divide that by the fourth term, we get minus 2. So that means that there's a common ratio in this series, and it is indeed a geometric series. It is a geometric series with first term 3, common ratio minus 1/2. And since we're summing only 10 terms, we're only summing the first 10 terms, then we have that n is going to be equivalent to 10. So the sum of the first 10 terms, using the formula that we derived, is going to be equivalent to 3 times 1 minus negative 1/2 to the power of 10, all divided by 1 minus 1/2. If we go ahead and we do some arithmetic here, we get that this is 3 times 1 minus, let's see, what is 1/2 to the power of 10? Or minus 1/2 to the power of 10. If we compute this, 1/2 to the power of 10 is 1 over, we have 1 minus 1 over 1024. All divided by 1 plus 1/2, which is just 3 over 2. So if we division by this fraction 3/2 is the same thing as multiplication by the reciprocal. So we'll have 2 over 3 times 3 times 1 minus 1024. 1 minus 1024 is 1023 over 1024. Here these factors of 3 divide out because I've got a factor of 3 both in the denominator and in the numerator. And we can divide out a factor of 2 here because 1024 is divisible by 2, and we have a factor of 2 in the numerator as well. So if we divide 1024 by 2, we get 512. So the sum of the first 10 terms is 1023 over 512. So therefore, the sum of the first 10 terms is 1023 divided by 512. Okay, so let's move forward to another example, another problem where we're told to determine the sum of this series below, and again, you can't just assume that a series is arithmetic or geometric. You have to you have to identify that it's either arithmetic or geometric. And the way to identify this as a geometric series is to see if there's a common ratio. So notice here that if I take the second term and I divide it by the first term, I get 3/2. And if I divide the third term by the second term, I don't get 3/2. Oh, okay, well, it's a good thing that we checked that this is a geometric series, because it's actually not. Notice that that there's not a common ratio between these terms. So this is not a geometric series. So that is because I made a mistake in this in the example for this question. So this should actually be not 9/2, but 9/4 in order to be a geometric series. So always check to make sure that the series is either geometric or arithmetic. Okay, so that's a lesson there. Okay, so here we have 1 plus 3/2 plus 9/4 plus ... all the way to 19,683 over 512. And now we actually do have something that's in the form of a geometric series, because the ratio of the second term to the first term is 3/2. If I divide the third term by the second term, I get 3/2. So the common ratio here is 3/2. So we have that r is equal to 3/2. We get that the first term, a, is just 1. And we know that the nth term is equal to 19,683 divided by 512. Okay. We don't know what n is. Now, remember that our formula for summing a geometric series, the one that we derived, is S sub n is equal to a times 1 minus r to the power of n over 1 minus r. So in this formula, I need to know how many terms are in the series in order to compute this sum. So I have to figure out what the value of n is for this term here. So recall that for a geometric series, we have that t sub n, the nth term, is equivalent to the first term times the common ratio to the power of the term number minus 1. So we know that the term is 19,683 divided by 512. We know that the first term is 1, and we know that the common ratio is 3/2. So now what we've done is we've set up an equation here, and we can solve for n. So in order to solve this equation, I've got 3/2 to the power of n minus 1. I want to try writing the left side so that it has the same base as the right side. And then the left side, or the right side has base 3/2. So I can write the right side as 3 over 2 to the power of, let's see here, this is going to be 2 to the power of 9 gives us 512. And 3 to the power of 9 gives us 19,683. So I know now that the bases are the same, that n minus 1 is equal to 9 rather. Oops. N minus 1 is equal to 9. And therefore, n is equal to 10. So when the bases are the same, and you have an equation like this, when the bases are the same on both sides, you can equate the exponents here. As long as this is there's a single term on both sides of the equation. Okay, so the next part of this question is to now compute the sum for 10 terms, where we have a being 1. So 1 times, and since I'm multiplying something by 1, the convention is not to write the 1 there. So I just have 1 minus r, and r is 3/2, to the power of 10, all divided by 1 minus 3/2. Now if I actually compute this, I get that this is 1 minus 3 to the power of 10. Let's see, 3 to the power of 10 is 59,049. Divided by 2 to the power of 10. And 2 to the power of 10 is 1,024. All divided by 1 minus 3 halves. So 1 minus 3 halves is just negative 1 half. And if I keep going on this, I get that, let's see, 1 minus 59,049 over 1,024. Well, I would just find a common denominator here. So I'm going to have 1,024 over 1,024 minus 59,049 over 1,024. So if we do 1,024 minus 59,049, we get 58,025, or minus 58,025. Divided by 1,024. And here I've got division by negative a half. Dividing by a fraction is this, or dividing by any number, is the same thing as multiplication by the reciprocal, provided that number is not 0. So we have that this is multiplication by minus 2 over 1, or let's just write this as times negative 2. We can do some dividing out here. Because 1,024 is divisible by 2. So we have that this is going to be 512. This will just be 1. And since I'm multiplying up negative times a negative, I'll get that this becomes positive. So what I'm left with is that this is equal to 58,025 over 512. So therefore, the sum of this series is 58,025 over 512.